Hello everyone, welcome back to my YouTube channel. My name is Ashok. In this video, we will discuss about very important topic of LWC, that is lifecycle hooks. This video will be divided into two parts. In first part, we will understand all the concepts related to lifecycle hooks. Then we will move on interview questions which are often asked from this topic. So if you are a beginner or experienced and want to learn lifecycle hooks in depth, or if you are preparing for interviews, then in both cases this video will help you a lot. I know this video will be quite long, but if you'll watch this till the end, then I don't think you would have any doubt or unanswered question in lifecycle hooks. So please watch this video till the end, okay? Now, first let's understand what is lifecycle hook. So we can say a lifecycle hook is a callback method triggered at a specific phase of component instance lifecycle. To understand lifecycle hooks in better way, first you need to understand component lifecycle. I mean how components actually works under the hood or how it renders in front of user. So let's refer this diagram to understand component lifecycle at high level. Here let's say this is the developer who create components on their local IDE, for example on VS Code. Now once done with the code, then we'll deploy it to the Salesforce org, and via internet that component gets stored somewhere in Salesforce server, which means now that component is available in org to add on various places like on Lightning pages, community or Experience Cloud pages, or at many places. Now suppose we have added that page on home page, which means whenever we will try to run or open that home page, then our component will also render there, right? So this is the one cycle. I mean, as a developer, we used to do such kind of things like we create components and deploy them to org and add on various places, right? Now, let's talk about another cycle. Let's say our customers are trying to open that home page in their browsers. Then what will happen? Our client will send a request to server and say, "Hi server, my user is requesting for home page. Please give me that." Then server will return home page content, and browser will add that content in DOM and will start rendering. Now, while rendering that page, browser will get to know that there is a different component added which is available on server. So again, client will send a request to server and say, "Hi server, now I need this component as well to show my user. Please give me that." Then what server will do? Server will return an instance of requested component. Now again, browser will add received content in DOM and start rendering, and whenever rendering will done, then we will be able to see our component on browser, right? So this is the overall cycle for a component to develop and visible in front of user. Now if we talk about various phases which are available in this rendering cycle, then first is the instance creation. I mean, as we have discussed, when client requests for a component, then server returns an instance of that component. So instance creation is the first phase, and second phase is the inserting or injecting that component element into the DOM, and third is rendering element on DOM or browser, and fourth is remove element from DOM, and finally we have error phase. So these three are involved when component get load on browser, and this fourth one will involve when component get unload or remove from browser. I mean, let's say we are navigating from home page to accounts page, then all the components which are available on home page, they will be removed from browser and render account page components, right? And fifth one is related to error. I mean, during component lifecycle, if any error occurred, then that will fall under fifth phase, okay? So these are the 5 phases which are involved in component load and unload cycle. I mean, in complete component lifecycle. But now, let's say we want to execute our custom logics during these various phases of component lifecycle. For example, let's say we want to get data from database on component load, or register and unregister events on component load or unload, and many other tasks we have to perform in a real world application on these various component phases, right? So now the question is where we can perform these operations. That's where lifecycle hooks comes into the picture. I mean, framework provides us few methods which will automatically get called during these phases. Like after component instance creation, constructor will get called. So if you want to perform your logic after instance creation, then that we can write under constructor. And if you want to run logics after component element added on DOM, then that we can write under connectedCallback method. And to run logic after component rendered on DOM, then we have to use renderedCallback method. And disconnectedCallback will get called after component removed from DOM. And if we get any error in component, and if you want to handle that, then we can use errorCallback method. Okay. Now I think you have fair understanding about component lifecycle. So let's open our presentation again and continue with lifecycle hooks. Now it should be easy for you to understand what is lifecycle hook. So let's go through definition again. A lifecycle hook is a callback method triggered at a specific phase of component instance lifecycle. Or in other words, we can say lifecycle hook is the special method that will automatically get called by framework at a specific phase to perform custom logics. I mean, when component get enter into a specific page, then framework give us callback and say, I have reached here. Do you want to execute your custom logics? If yes, then use specific lifecycle hook. Okay. For example, once component get rendered into DOM, then framework will automatically call renderedCallback method. So if you want to execute any logic after component render, then that we can write in renderedCallback method. Okay. And why these hooks are required? To perform custom logics on component various lifecycle phases. Right. As of now, we have understood what are lifecycle hooks and why we require them. Now let's see what all hooks we have. So in LWC, we have 5 lifecycle hooks. First is the constructor. And as we have discussed, this will be called when component instance get created. Why this hook should be used or what all actions we can perform here, that we will discuss in coming slides. Next is the connectedCallback, which will get called when component element inserted into DOM. And third is the renderedCallback. It will get called when component rendered into DOM. And next we have disconnectedCallback. This will get called when component get removed from DOM. Here DOM means document object model. And in case of any errorCallback will get called. Okay. So these are the 5 lifecycle hooks we have in LWC. But here we have one more additional method, that is render. Behavior of this render method is quite similar to the lifecycle hooks, but it is not a lifecycle hook. It is a protected method that is available in Lightning element class. And why we use it? To conditionally render template. How we can conditionally render? That we will see in some time later. Okay. So in nutshell, in LWC, we have 5 lifecycle hooks and a render method, which is also similar to them. Alright. Now let's see their execution order, or in which order all these hooks will get called. For example, here in this component, we have used all these hooks. Now the question is, in which order these methods will get called, or who will call first, then who will be next. So for each component, mainly there can be 2 phases. First is the loading phase and second is the unloading phase, which means when component renders on browser, that is called loading phase, and removing from browser is called unloading phase. Okay. So first, if we talk about loading phase, then as we have discussed, to load a component in front of user, browser will send a request to server, then server will return an instance of that component. So whenever instance will get created, then constructor will get called. We can say this is the first method which get called in component lifecycle. And after receiving component instance from server, browser will add that component element into DOM and call connectedCallback method. Then elements rendering will start. I mean, whatever elements or tags we have added in component HTML file, they will start rendering on browser. For example, in this component HTML file, first we have lightning card, then we have div, then under this div, we have lightning input button and a child component. Right. So after calling connectedCallback, these elements will start rendering, and whenever all these elements will render, then renderedCallback method will get called. But if we are calling child component in our component, then before calling renderedCallback of parent, DOM will start execution of child component. I mean, same flow will start for child component, like child constructor will get called, then child element will added into DOM, then child connected callback method will get called, then content rendering will start for child, and again if child is also calling another child, then execution will start for that component, and once all the components will render in child component, then rendered callback method will get called first for child, then for parent component. Okay, so here we can say if we have parent-child relationship in components, then before calling rendered callback method of parent component, control will directly shift to the child, and once child component rendering will done, then control will shift back to the parent and call rendered callback method of parent component. Okay, so here we can say constructor and connected callback will execute from top to bottom. I mean first parent component's constructor will get called, then for child component, and same behavior with connected callback as well. But if we talk about rendered callback, then it is reverse. I mean order is bottom to top. First child component's rendered callback method will get called, then for parent. Okay. Now you might be thinking why rendered callback execute from bottom to top. So the reason behind this is child component is also added an element in parent, and you know rendered callback method will get called when all the elements will render. So without rendering child, how we can say that parent component is completely rendered, right? So first all the child components will render and then parent will consider as rendered. Okay. Now to demonstrate this in front of you, I have already created two LWC components, Lifecycle Hooks parent and Lifecycle Hooks child, and called this child component into parent, and also added all the lifecycle hooks in both components with a message. I mean here in parent component, we have created constructor and printing this message in log, like in parent constructor, and in connected callback, we are printing in parent connected callback, and same thing in other methods as well. And similarly in child also we have added all the lifecycle hooks and also printing message. Okay. And for demo purpose, I have already added these components on home page in my org. So let's open that to see in which order these messages will print. Here we can see our component. Now let's refresh this page and open browser console. Alright, here first we can see in parent constructor, then parent connected callback, and then before calling parent components connected callback, child component execution started and called child component constructor. So we can see in child constructor message here, then after child component connected callback called, and then first rendered callback called for child, then for parent, right? So this is the execution order in case of loading phase. Here constructor will get called first, then connected callback, and if you have child component, then before calling rendered callback for parent, child component execution will start, and after rendering all the child components, parent component's rendered callback method will get called. Okay. Now if we talk about unloading phase, I mean when component is getting removed from DOM, then first parent component will get removed from DOM and call disconnected callback method for parent, and then child will remove and call connected callback method for that. Okay, so disconnected callback also call from parent to child. I mean first parent component's disconnected callback method call, then for child. Alright, now I think you have fair understanding about in which order these lifecycle hooks get called. So now let's move ahead and see all these hooks one by one in depth. First we have constructor, when it will called, when component instance is created, in which order it will called. I mean if you have multiple components in same hierarchy, then in which order it will called, from parent to child. Or we can say parent components constructor will call first, then child components. And now let's see key points related to constructor, like why we should use it, and what we can do inside this and what we cannot do. So first of all, when we create constructor inside component, then first statement must be super without parameters. It means first we have to call super method inside constructor like this. Why this is required? Because it will establish the correct prototype chain and value for this. We should always call super method before using this keyword. For example, we can't write like this. It will throw an error. I mean, we can't use this keyword in constructor before calling super method. We can use it after calling super method like this. Okay. Next point we have, we can't access component elements inside constructor. Why? Because they are not yet rendered on DOM. So if someone asks you a question like, can we access component elements in constructor? Then answer will be no, because in this stage, they are not rendered on DOM. Okay. Next point is, we can't display custom events in constructor. That's why navigation services cannot be used here, because they also use custom events internally. Okay. Next is, we can initialize private properties in constructor. It means whatever private properties we have in component, we can assign value to them in constructor method. Like let's say we want to set hello in username property on component load, then we can write like this. But here question is, can't we assign values in public properties in constructor? Then answer will be yes, we can assign value in public properties as well, but that doesn't make any sense. Why? Because in public properties, value get assigned from parent component after constructor called. So whatever value we will assign in constructor, that will be replaced with the value which we passed from parent component. Okay. So that's why we should only initialize private properties in constructor. Next point is, we can call apex methods inside constructor. Yeah, that's true. If you want to get data from Salesforce database on component load, then we can call apex methods or UI record API methods as well in constructor. Okay. So this is all about constructor lifecycle hook. Or in nutshell, we can say constructor can be used to assign values in private properties or to call apex methods to get data, but here we can't access component elements. Now let's discuss about connected callback. When it will called? When component is inserted into DOM. What is the execution order? It will call after constructor, and in case of parent-child component hierarchy, it will call top to bottom. Or we can say parent components method will call first, then child components method. And now let's discuss key points related to connected lifecycle hook. First point is, here we cannot access child elements because they are still pending to render, but we can access host element here. Which one is the host element? Let me show you here in browser. Here it is. It has same name as component in kebab case. So this main element is called host element, and we can only access this element in connected callback, but we cannot access child elements like this lightning card or other elements. I mean, in connected callback, we can only access this parent element and do manipulation here, but whatever child elements we have inside this, we cannot access them here because they are still pending to render. Okay. Next point is, here also we can initialize private properties. I mean, it's completely fine if we initialize private properties in connected callback instead of constructor, but we should not initialize or assign values in public properties here, because when connected callback method will call, at that time public properties already assigned values from parent component. So if we will assign values here in connected callback, then whatever values we have passed from parent, those will be replaced with connected callback values. Okay. And here also we can call apex method and UI record API methods to perform card operations. And also here we can subscribe and dispatch custom events and use Lightning Message Service and navigation services. Okay. So if you have a requirement to subscribe Lightning Message channel or custom events, then connected callback is the right place. Now let's discuss about rendered callback. When it will invoked? When component elements completely rendered on DOM. In which order it will called? In parent-child relationship, from child to parent. I mean, child components method will call first, then parent components method. And if we talk about key points, then first is, here we can access component elements including child component. So in component loading phase, this is the callback method where we can access all the component elements including child component. I mean, in constructor, we cannot access any element, or in connected callback, we can only access host element, but in rendered callback, we can access host element, child elements and child components as well. Okay. This callback method is generally called multiple times, and here also we can call apex method and UI record API methods. But I think that's not a good practice because as discussed, it may call multiple times. So if we are performing any logic here, then we have to put a check to avoid duplication. And this is also not recommended to call apex methods and dispatch custom events from here. Now you might be thinking then why we should use rendered callback. So this is mainly used to access or modify component elements, or we can say to do DOM manipulation. For example, let's say you want to dynamically add CSS or other attributes on element, or let's take another example. Let's say we have an amount field, and if amount is less than 0, then we want to show text in red color, or if amount is greater than 0, then text should be in green color. So to achieve this requirement, we can access this element in rendered callback using query selector or LWC refs property and assign CSS class on the basis of amount value. Okay. So rendered callback mainly used to perform DOM manipulation. Now next we have disconnected callback. We can say this is just opposite to connected callback. Connected callback get called when component added into DOM, and disconnected callback called when component removed from DOM. And order will be same as connected callback, parent to child. And why we should use it? So this is mainly we use to clean up the work we done in connected callback. For example, to remove cache and to unsubscribe event listeners and messaging channels. Because when component is unloaded from DOM, then we should obviously remove all the subscription which we made for this component, because component is no longer available. So to perform these kind of things, we can use disconnected callback. Okay. Next we have error callback. So as name suggests, it will get called when any error occurs in component lifecycle, and it will contain two parameters, error and stack. These parameters help us to get error details, like what is the cause of error and where error occurred. And if you have parent-child relationship in components, then only parent component's error callback method will get called. It means if we get any error in child components, then that can be handled only in parent component. Okay. Now let's discuss about render method. So as discussed earlier, this is not a lifecycle hook, but work in similar way. I mean, it is also automatically called right before and after connected callback. And why we should use it? So this is mainly used to show multiple templates conditionally. What does it means? For example, let's say on the basis of some conditions, we want to show completely different UI to user. I mean, based on conditions, we want to show and hide many controls, or want to show in different positions or in look and feel. Then instead of doing all the manipulations in single component HTML file, what we can do? We can create separate HTML template files and write our logics accordingly. And at last, in render method, we can check our conditions and return a specific template to render. For more clarity, let me show you this thing in practical. Here in child component, we have created this render method, and here what we are doing, we are checking that if username value is rendered demo, then we want to show different UI. So we are returning template 2 from here, else we are returning template 1. What are these? These are the HTML template files which we have imported here and created in same component bundle. Here you can see this is the lifecycle hooks child, and this is the another HTML template, lifecycle hooks child 1. So first we have imported these HTML templates here. Then in render method, on the basis of our conditions, we can decide and return a specific HTML template. Okay. Now let me show you in browser how this actually works. Here if I type render demo and click on submit, then you can see a different look and feel. But if I type anything else, then you can see a different template. Okay. So anywhere if you have a requirement where on the basis of some conditions, we want to show different look and feel, then instead of doing all the manipulations in single HTML file, we can create different HTML files, and using render method, we can render them conditionally. Okay. So that's it in the first part of this video, where we have learned all the basics and advanced concepts related to lifecycle hooks. Now let's move into another part of this video and discuss about interview questions which are generally asked from this topic. Though most of questions answer we have already covered in our session, but let's see them again from an interview perspective. Alright, so let's start with the first and very basic question, that is, what are lifecycle hooks in LWC? So as discussed, lifecycle hooks are the special methods that will automatically get called by framework at a specific phase of component instance lifecycle. Okay? If you want to explain more here, then you can explain whatever we discussed in the beginning of this video. Next we have, why should lifecycle hooks be used? Then answer will be to inject custom code or to perform logics on various pages of component instance lifecycle. For example, to get data on component load or to subscribe and unsubscribe custom events. Next we have, is it necessary to use lifecycle hooks in LWC? Then answer will be no. These are completely optional to use. I mean, if you want to perform something on component different phases, then we can use respective lifecycle hook. Next question we have, how many hooks are there in LWC? So mainly we have 5 hooks. First is the constructor, then connectedCallback, then renderedCallback, then disconnectedCallback, and errorCallback. But apart from these, we have one more additional method, that is render, which also behave as lifecycle hooks. I mean, it is also automatically get called in component lifecycle. Next we have, what is the execution order for lifecycle hooks with or without child components? So as we discussed, first parent components constructor will get called, and as of now public properties are pending to update. They are parallelly getting updated, but in the meantime parent component will insert into the DOM. Then right after that, connectedCallback method will get called on parent component. Now parent component will started rendering, and if you are calling another component in this component, then before calling renderedCallback method of parent component, child component execution will start and follow same steps for that. And once child rendering will complete, then renderedCallback will call for child component, then for parent. Okay, so this is the flow diagram for lifecycle hooks. Next we have, what is the use of render method? So as already discussed, we use render method to conditionally render different HTML template files. For example, let's say we are creating a component to show accounts detail, but we want to show completely different UI for active and inactive accounts. So instead of writing all the conditional logics in single HTML template file, we can create different HTML files for active and inactive accounts, and using render method can return and render template as per account status. Okay. Next question is, can we access component elements in constructor? Then obviously answer will be no, because they are still pending to render on DOM. Next is, can we access component elements in connectedCallback? So here we can only access host or root element of the component, but we can't access child elements because still they are pending to render. Next question is, can we access child components public method in renderedCallback? Then answer will be yes, we can, but that method should be public using API decorator. Next question is, where third-party resources should be loaded in LWC? Sometimes we have to use external script and CSS files in our LWC components. So the question is, in which phase we should load them? Then we can say, we can load them in connectedCallback and in renderedCallback. In these both methods we can import or load external resources, but renderedCallback would be best place if you want to access current component elements or want to do DOM manipulation. Next question is, which lifecycle hook get called when public property value gets changed from parent component? Then answer will be renderedCallback. But which components renderedCallback? Is it parents or child? Well, it's depend on the code or scenario, like how you are passing value from parent. I mean, if you refer that property anywhere in HTML template, either in parent or child, then renderedCallback will automatically get called for that component. So here key point is, if we use any reactive property on HTML template, then whenever value will get changed in that property, then renderedCallback will again get called. Okay. So here if you are passing value as attribute like this, then parent component's rendered callback will get called. And if you are using this property in child HTML template like this, then child rendered callback will also get called. Next we have which one will execute first, @wire, constructor or connected callback. So obviously constructor will get called first and start initializing properties with default value. Then second, wire service will get called, but it returns a default object with undefined values. I mean, in first call of wire service, we won't get actual method response or data. First time it returns undefined in data and error both, and then connected callback will start executing, and after that wire service will again get called. This time it will bring actual response which we are returning from our method. Okay, so in nutshell, constructor will call first, then wire, then a connected callback, then again wire service. Next we have when should call apex method using wire decorator instead of connected callback. Alright, wire service helps us to call an apex method and store response into browser case. So if you are going to read data that really get changed, then instead of calling apex method using imperative approach, we should call that using wire. So response will get stored into cache, and for subsequent request, no server call required. I mean, client will not call server again and again for same data. That request will be fulfilled from client side cache itself. And second reason is, if you want to implement reactive behavior, then we should call method using wire decorator instead of connected callback. Reactive behavior means whenever input parameters value get changed, then system should automatically get data again as per updated input values. For example, here we are calling an apex method using wire decorator and passing account ID as input with reactive behavior. Now, whenever we will update value in this record ID property, then component will automatically call this method again and get context for updated account ID. Okay? And to pass parameter as reactive, we have to add $with property in single quote. But if we want to use apex methods data in connected callback, then instead of calling method using wire, we have to call method in connected callback using imperative approach. Like this. Next is connected callback versus rendered callback, or what are the differences between connected callback and rendered callback. So first, if we talk about connected callback, then it executes when component inserted into DOM and it flows from top to bottom. I mean, parent components connected callback method will call first, then child components. And here we can't access child elements and child components. And generally we use it when need to perform something on component load, like to subscribe custom events and message channels, and to get data on component load from Salesforce or other systems. And now if we talk about rendered callback, then we can say it runs when all the elements rendered or when any reactive value get changed. And generally we use it when need to access component elements or to perform DOM manipulation or to load static resources. Okay. Next is what will happen if we change value of a property in rendered callback and that same property is referred on HTML template. Something like this. Here we have declared a count property in JS file and increasing value of this property in rendered callback and also use this same property in HTML template. Now the question is, what will happen? Will this component render successfully or not? Well, in this case, rendered callback will be called again and again recursively, which will result in an infinite loop. So we should avoid updating reactive properties in rendered callback or should not update component state in rendered callback. Okay. So that's it in this video where I tried to explain everything related to lifecycle hooks with some interview questions. If this video helped you to learn something new, then please like and subscribe my YouTube channel. This is completely free for you and will give me motivation to create more such kind of videos for you. And literally guys, it takes lots of efforts. So please support me by like and subscribe, and also share this video with your friends and colleagues. And also don't forget to share your feedback and questions in comment, or you can connect me over LinkedIn or mail. Thank you so much for watching. We'll see you in next video.